My name is Gabby, and I'm a member of the Saskatchewan Science Centre's Go Science Outreach team. I'm going to be talking about owl pellets and doing a dissection on one. An owl pellet is a ball of undigested fur and bones that owls basically throw up. This undigested fur and bones are from the prey that they eat. Owls eat small rodents and birds, and when they eat their prey, they actually eat it whole. If we look at this diagram of the anatomy of an owl, you'll see that like other birds, owls have two chambers in their stomachs. The first chamber, which is called the glandular stomach or proventriculus, is where all the digestible parts of an owl's meal are liquefied. The meal then passes into the second chamber, which is called the muscular stomach or gizzard. This is where hard structures get grinded down and the digestible food squeezes out into the intestines. It can take up to 10 hours after the meal, but eventually the owl will regurgitate or puke up the remaining indigestible fur, bones, and teeth. Thanks to the churning acids in the owl's stomach, the indigestible material is molded into a tightly packed mass, the pellet, which looks like this. Now today, I am going to be showing you how to dissect an owl pellet. Here at the Science Centre, we have a great horned owl named Bubo, so that is where we get our pellets from. To do this dissection, I need a few tools to get started. I made sure to have my lab coat on, gloves, and my glasses on for safety. I also have a couple paper plates to pull my pellet apart on, some tweezers to put small bones out on it, and a bone chart to figure out what kinds of bones I have. The final part is making sure your pellet is disinfected. If you've already bought them online, they're most likely already disinfected. You can easily do it yourself though too by wrapping each pellet in an aluminum foil and placing them in an oven preheated to 325 degrees for 40 minutes. Now that I have all my safety supplies and tools, I'm going to get started. There isn't really a specific way to do this, but I like to just dive right in by pulling the pellet apart and displaying all the materials on the other plate. So as we're pulling it apart in here, you'll notice that it's coming apart pretty easily. That's because this pellet specifically is just pretty old. And when they are older, they're going to be a lot easier to pull apart versus some that are fresh. So as I'm going through here, I'm going to separate all the bones that I find, trying to pull off as much fluff as I can. It's not a huge deal if you don't get everything off, but it should come off pretty easily. You'll notice as we're looking through that we're going to find a lot of bones that are a lot smaller than you'd expect. Bubo, our owl at the center, only eats mice, so we're only going to find mice bones. But owls have a pretty wide variety of things that they eat, so you could find many different kinds of bones in owl pellets, depending which owl it is. So to know that a pellet is done, usually I try to make sure that every single tiny little piece of fluff is just flattened out. Sometimes things can get pretty small and they just get stuck. So obviously you're not going to be able to pick up every single tiny little bone that you find in pellets, but I like using the tweezers if you want to get some of those smaller ones. Okay, so it looks like I've found all the bones I think that we're going to find. Now we're going to do the fun part, which is actually trying to figure out what they are. So we're going to bring this plate closer, put that one over there. Now what I like to do usually is separate everything out. So just, obviously you're not going to know just by looking at them what they are. So looking here, we definitely have some arm and leg bones. So those are going to be those longer ones. And obviously these could have been broken as well, right? Because when your owl is eating his meal, he or she is not going to be very gentle. So a lot of bones you'll find will be snapped and broken, so you might think you have something when it's something else completely different. So what we have separated here, I have some arm and leg bones. I'm going to make an educated guess that these are going to be either ribs, and this could also be another leg bone. My favorite part, though, is these little bones. These are actually mandible or jaw bones, I believe. So if we turn them around here, you can actually see the little teeth. So this would be one side, and this could be the other side. It's also hard to tell, though, because, you know, looking at it, it could also be a nail, end of a nail of a mouse, so it's kind of hard to tell, and they all look kind of similar. That is my educated guess. So this is what we found in this first pellet. I actually went ahead and dissected a bunch of other pellets as well, and we found a ton more bones. Sadly, I didn't find a whole skull. Those are pretty rare to find, so if you happen to be ever doing this yourself, if you find a skull, consider yourself very lucky. So looking at the other plate here that I have of all of the other bones that I found in our other pellets, some of the bigger, cooler things that I found is a mandible jaw with the bottom half as well, which is kind of rare to find because they can just break really easily, and I actually have already broken this one a little bit. But this is just the bottom part of it, and then this is the top half of its jaw. So as you can see, we have found a ton of different kinds of bones from these pellets. Studying what is inside an owl pellet is a fun and interactive way to learn more about owls and where they and their prey belong in a food web. If you enjoyed this video, check out our website to see more cool videos and posts. You can even watch a live cam of Bubo, our owl, that I mentioned and learn all about great horned owls. Thank you for watching, and as always, have a great day.
Hey, how you doing? Tommy Tungsten here for Elements R Us with another super special sale. Today's item is something you literally cannot live without. Your friend and mine, oxygen. Everything that breathes oxygen. Birds, fish, you, me. Even plants use it to respire. So it's a pretty sound investment if you catch my drift. Now oxygen don't burn by itself. But if you were to say roast a marshmallow over a campfire, you still need some oxygen in the air to get your treat nice and toasty brown, just like Mama used to make. Oh, and if you ever seen them aurora borealis, them northern lights, well, you don't get none of those real pretty yellows and greens without the oxygen in the atmosphere. Oxygen. You need it, we got it. Come on down to Elements R Us and breathe in a free sample today. And when you get there, tell them Tommy sent you. Capiche?
Hello everyone, my name is Sally Science, and I love it when you send in your curious questions for us to explore together. And today we have an awesome question from Noah.
Why do birds fly south in the winter?
Thanks, Noah, for sending in this great question. Scientists have been wondering the answer to this for a really long time. Would you believe me if I told you that birds didn't fly south for the winter at all, but they actually flew to the moon instead? No, silly, I'm just joking. They don't fly to the moon. But a long time ago, there was a scientist named Charles Morton who did think the birds flew all the way to the moon for the winter. How crazy is that? Well, we know now that birds travel all over the planet, thousands of kilometers in distance in the spring and fall in a process we call migration. And birds aren't the only creatures in our ecosystems that migrate. Fish, turtles, whales, caribou, all of them move across the planet from one area to another. And do you know why they travel so far across the planet? Well, the answer is really all about food. This is the Earth. Okay, it's not the real Earth, it's just a little mini version. But birds know how to get around the Earth really, really well because they have an amazing sense of direction. If you went outside right now, would you know which way was north? Well, the birds would. There are 4 main directions that we use to find our way around the planet. Here at the top is north, here at the bottom is south, and then we have east and west. And there are so many different kinds of birds on Earth that fly in so many different directions, it would take me all day to talk about them all. So today, we're just going to talk about the birds that migrate from north to south and south to north, just like the Canada geese do. Do you know in the fall, when you can feel the air get a little bit chillier and you have to put on a warmer coat, and maybe you can see your breath? Well, birds who migrate also feel that chill. And when they get a little chilly, they know it's one of the signals that they have to start heading south. And when the air gets cooler, there are also not as many things around for the bird to eat, like insects and bugs. So they take to the skies and fly to where it is warmer and there are lots of insects and bugs to eat. How cool is that? And you're probably wondering, Noah, if it is so warm down there with so much to eat, why bother flying all the way north again in the spring? Well, birds migrate northward in the spring for more snacks. Eventually, the south gets cooler and we get warmer. And as we get warmer, there are more bugs to eat. So they take to the skies again and fly northward just as the bugs are starting to buzz around and they have a big feast. But the springtime is also the time of year that birds lay eggs and start new families. And many different types of birds return to the very same place every year to start their families. And they've been doing that for a really, really, really long time. But what is super cool part about all of this is not the why do they migrate, but how do they migrate? I mean, they don't have a map or a GPS or a compass. Or do they? Scientists are still trying to figure this out, but they have discovered traces of magnetite, which is a naturally occurring magnetic mineral in the beaks of a lot of species of birds. And scientists now think that birds use those traces of magnetite as a compass to find their way all over the planet in the spring and in the fall, year after year after year. How amazing is that? Thanks, Noah, for sending in this awesome question. If you have a curious question that you'd like to explore with me, please send it in. I would love to hear it. I hope you all have a super duper day, everyone. And this is Sally Science, signing out.